just to start us off, a quick thank you to everyone who participated in the Sweet 16 of wall assemblies. And by participating, I don't just mean entered a wall assembly, but everyone who obviously did compete, but certainly those who commented and moved forward the conversation about how to build better, questioning assemblies, offering criticism, and basically just keeping the conversation going. That was the whole point of the competition, was to learn from each other and to advance building practices for all of us. So very sincere thank you to everyone who participated in that aspect and voted. And basically at this point, I want to turn it over to the star power. We've got some top level competitors here from the assembly. We've got Christine Williamson here to break down all of the building science do's and don'ts. So I'm going to kick it over to Joe Nichols, my partner with Joe Cook in running this KCBS and beer. What do you say, Joe?
Hey, Travis, thanks. We're just going to do a quick around the horn. If y'all could just say hello and maybe share what you're drinking tonight. All beverages welcome. First, we'll give a shout out to Rob, who made all this possible with Fine Home Building, setting up the webinar. Rob, thank you.
Yeah, no problem. I'm just pushing the buttons here to let you guys do your good work.
Right, and did you have a glass of wine or something?
Oh yeah, I've got a nice glass of Cabernet right here. So
beautiful.
Really classing it up over here.
We got Joe Cook, Travis's business partner and a co-coordinator of BS and Beer KC.
Yeah, I'm drinking Alaskan Brewing Company Husky IPA tonight. And thanks for doing this, Joe and Travis and Christine and Ben and Mike and everybody. Real glad for it.
Moving along, I'm going to save our finalists and Christine for last. Travis, I guess you kind of already said hello. What are you drinking, though?
I got a special gift in the mail from my friend Dan, who runs the Jew Brew up there in Pennsylvania. That's Dan Edelman. He made me this cucumber saison and sent it my way. And I have to say, it's pretty refreshing. So pretty excited about that bonus beer.
Love it. We've also got Matt Blomquist, Build, Learn, Teach on Instagram. Matt, you want to just tell us what you do and tell us what you're drinking?
Yeah, so I'm actually just drinking water, but only because after this, I'm still working on a final project for a master's class, which is funny enough, is on exterior wall assemblies.
You should be teaching that class.
Right. This one's for commercial settings and stuff, so it's a little bit more out of my realm, but nonetheless, I'll have my beer after that. Got to keep the clear mind for another couple hours. I teach at Taylorville High School in Taylorville, Illinois. We just relaunched our house building program, and we've put a focus on bringing to our small community the idea of building higher performing houses. So even though I've been in the building industry for quite some time now, residential wise, this is getting into this deep into the building science is definitely new for me. So I'm still at a very beginner level, but it's been fun so far.
Love it. Thanks for being here, Matt. Next, we'll go to Mike Maines, the first of our two finalists tonight, trying to bring home the belt. Mike, I'll let you introduce Chris as well.
Yeah, I'm Mike Maines. I'm a residential designer in Maine, and I do some building science consulting, and I write for Fine Home Building. And the BS and Beer name was my brainstorm, so that's my contribution here. I am drinking a very spicy herbal tea out of my Ultra Air in Santa Fe mug, and I'll introduce Chris Corson. Everybody else submitted walls they designed. I submitted my favorite wall, which Chris designed. He owns and founded EcoCore High Performance Buildings in Searsmont, Maine, and they do panelized passive house assemblies.
Chris, you enjoying a beverage this evening?
Me?
Yeah.
Oh, okay. Hi, everybody. Nice to meet you. Yeah, I'm out of hydroxychloroquine, so I'm actually drinking gin and quinine instead.
Hey, do what you can, I guess.
That's right. Do the best we can.
And our second finalist, who's actually ready to fight, Ben Bowley. Introduce yourself, please, Ben.
I'm Ben Bogey. I'm production manager, lead carpenter for Colbert Building here in Portland, Maine. Self-professed bearded weirdo and obsessive about all things building. And tonight I am drinking the last of my secret stash of the inimitable Heady Topper double IPA out of Vermont.
That's great. I love it. I guess we'll also acknowledge Steve Basic is here with us. Steve said he's on a work computer, so he has no video, no mic, but he can hear us. So he might jump into chat here and there. So we're really thankful to have any input from Steve is always welcome. So I guess before I introduce our last guest, I'll do just give everyone a quick idea of what we're doing tonight. We're gonna let Christine do a little presentation here about Perfect Wall. And then we're gonna just do a little back and forth with our panelists. We're gonna try to wrap everything up by 5 o'clock, but we will have additional time available for Q&A if anybody has anything else they wanna add. Of course, questions in chat, always welcome. Christine at Building Science Fight Club on Instagram. There's almost too much to say, so I'll just kick it over to you and let you introduce yourself and get going.
Well, sounds good. I'm drinking tea because this is not the end of my day. So now I'm extra thirsty hearing what y'all are drinking. So maybe by the end of this, I'll yell to my husband and have him bring me a beer. But let's get started. I love this contest. I think it's fantastic. It's such a fun way of talking about different types of wall assemblies and performance and getting into the nitty-gritty of why we make the decisions that we make. What values are we prioritizing over others that make us choose one thing and not another thing? And what risks are we contending with while we do it? So it's just a really great opportunity to do that in good fun. And I thought actually that when y'all asked me to come and join you, that it might help to go through a wall assembly that is not presented in this contest at all, and use it as a jumping off point to talk about the principles of water management, of air control, of really principles of construction and building science that we use to inform our decisions and give us kind of a common language to be able to discuss this stuff. So with that in mind, I've got some slides that I can show, I hope, share screen, look at that. Let's see. Oh boy. Oh, huh. Let's try this. Share. Thanks, guys.
It's working.
Is it? I don't know what you guys can see, but I hope
we
you
can
see
the
it.
whole screen. So now we have the slide.
Now, okay, good. Okay. So I think it helps when we talk about this kind of stuff. It helps to keep in mind what it is we're doing with this. What's going on? What is our purpose in putting these materials together to form a wall? And the reason I say that is because the science gets so complicated that we sometimes think of, a water control layer as being good in and of itself, or controlling vapor as being something mandatory that we have to do. Well, we don't really have to do these things. We have to do them because we're trying to achieve something else. So when we look at the bigger picture goals for our enclosure, the first thing we want to do is we want to make sure that whatever we do, we're building something that's structurally robust and fire resistant. So nothing that we do to mess around with the wall assembly we're going to want to make stuff structurally unsound or likely to burn down. So those are the kind of prerequisites. The next thing we want to do is we want to be able to create some sort of interior environment. That's kind of the whole point of our buildings. A lot of times architects, or in architecture, we think of buildings more like sculptures or pieces of art, and that's fine, except we have to live in them. And what we're really doing is we're creating an environmental separator. So we want to create a certain kind of environment in one spot that's different from the environment somewhere else outside. So creating a comfortable interior environment, and what goes into that comfort, we want it to be thermally comfortable. We want it to have, good indoor air quality. So we don't want dust and pests and allergens and mold. We want it to be quiet inside. These are the types of things that we're trying to achieve. And then finally, we want to make sure that our walls, our assembly is durable and as low maintenance as possible. So this is why we want to manage the risk of water-related failures. So leaks will damage the materials that we're building with. They'll be a nuisance to occupants, and then they cause all kinds of things that are nasty, like mold, which then in turn affects indoor air quality. It damages interior finishes. It gets us sued, all that kind of stuff. Not fun. It causes us to prematurely have to replace things that we don't otherwise want to replace, like prematurely replace claddings, roof, whatever. You get the gist. So how do we go about actually doing this, creating a comfortable interior environment and not damaging the materials that we're building with? The first thing that we do is we provide control layers. So we use materials that control water and air and heat and water vapor, and we put them together in a particular order so that we can both control the interior environment and, next up, protect the materials themselves. So we've got to pick the right materials and arrange them properly to minimize how wet they get and to allow them to dry when they get dry. And then the third thing that we need to do to create this interior environment that is durable is we need to provide some sort of way of conditioning that environment. So that's really outside of the realm of our discussion today, but that's why we're doing this. We're creating an enclosure so that we can do something with that enclosed space. And most of the time, for our purposes, what that means is we have a mechanical system that conditions that air. So the enclosure deals with the first two bullet points here, and that's what we're talking about when we're talking about this competition. But the third component there is mechanical system design. So the control layers, what are they? Water, air, heat, and water vapor. These are things that we want to control. And it's very helpful to think of these things as loads on the enclosure. So this is how we approach structural design and fireproofing, and it's helpful if we approach enclosure design the same way. So we think of water not just as a thing, but it's a load. And our assembly needs to be resistant to the type of exposure that we're going to expose it to, that we're going to put it in. So this is very contextual. Same thing as structure, right? We don't ever design buildings, or we don't design buildings or anything that never, ever, ever falls down. We design our buildings so that they can resist the structural loads that we want to put them under, the most common structural loads, and then we design them in a way that if we're in a situation where those loads are exceeded, if we have a failure, it fails in a way that's designed to minimize loss of life. So we want to take that same sort of attitude towards water, air, heat, and water vapor. What we're really trying to do is make our assembly respond to the most common water loads, air loads, thermal loads, and water vapor that they're going to see over their life, and design them to resist those loads, and if they fail in a way that's designed to minimize the actual impact and disruption. Because if there's one thing that I'm sure we all know is that it's very hard to do this stuff, and we're not perfect. So take the potential for failure into account. So I guess I just covered this, but I get students to memorize this sentence. And I think this is really what separates professionals from amateurs in our profession. So for water infiltration to be problematic, the wetting a wall experiences must exceed its capacity to store and redistribute water for long enough to damage the materials that compose it. And again, this goes right back to what is it we're trying to achieve. We're not trying to manage water because managing water is good in and of itself. We're doing it because we're trying to achieve an interior environment in a durable way. So this is very hard for a lot of people, right? They get into this very black and white kind of thinking about our assemblies, and they think, well, if water gets past my water control layer, I have bigger problems to worry about. I shouldn't be focused on interior drying, or whatever. We've heard a lot of these arguments before, but that's not how this works. This is we're not doing this just to do it. We're doing it because we're trying to achieve something else. So, what is the context? What are the materials we're building with? What are the loads in the setting that we're designing this stuff in? This is how we ought to be thinking of these things. And I've used this example for water, but it applies to the other things that we attempt to control in our buildings as well, right? Air leakage isn't in and of itself, or air infiltration isn't good or bad in and of itself. It's how it contributes to what it is we're trying to do. So we want to restrict airflow in our assemblies for all kinds of reasons, to control condensation and also to better condition that interior environment. But we're not doing it just for fun. And if we fail, if we're not very good at it, there's sort of degrees of how good or not good we are at controlling air, and there are degrees of consequences to that too. So these things are like a continuum, and you have to use professional judgment to determine where we should be on that continuum. So where are these loads coming from? Fortunately, we have only 3 places. We've got the outside, the inside, and the materials themselves. So most of the time we're dealing with water, so we'll start with that. So water can come from the outside, and mostly that's rain and groundwater. But air is outside, heat, wind, cold, humidity, that kind of stuff, they're all outside. Inside, people and our stuff, breathing, cooking, cleaning, etc. Big interior, we have interior moisture loads as well. This matters a great deal, in particular in cold climates, and we'll get to that in just a minute. And then the materials themselves, we build outside still, usually, although not on some of these proposed walls, but for the most part, we're building outside, and the materials we start with start out wet sometimes. Sometimes they get rained on before we put them together, and we need to account for that in our discussion and in our decisions. So, the perfect wall. This is a concept that my dad came up with. He didn't invent the physics. He has no monopoly on that. He didn't invent any of this. But he did invent the terminology, and it's a really helpful way of approaching. It's a helpful starting point to talk about walls in general. So this is a conceptual perfect wall. It's not a construction document or instructions, but it's a concept that's really helpful to think about how we manage these control layers. So what are we looking at when we're looking at the perfect wall? Basically, we have a structure. Our structure goes up first. We have our water control layer, our air control layer, and our water vapor control layer outboard of the structure. And then we have insulation outboard of that. So the control layers are outboard of the structure so that the structure is protected. That's the best spot for them in order to protect the structure, which is really important to us. And the insulation is our outermost of the control layers. And this wall will work on every construction type, every climate. This works commercially, it works residentially. This is the perfect wall, conceptually. So why does it work? So I think it helps to maybe slow down a little bit and go through summertime, wintertime, and actually I can't see this part of my screen, so I don't know. Does it say summer? Oh, it says winter, right?
Cold, hot.
Yeah, okay. Winter outside. Yeah, okay. I have your faces on the side there, so I can't see some of my screen. But anyway, so why does the perfect wall work? So we're going to slow down and think about the wintertime condition here. So the control layers are on the outside, and they're best positioned to protect the structure and create that interior environment that we desire. Where is our risk of, oh, actually, we'll put a pin in this for a sec. Don't stress over this for a minute here. We obsess a lot of times about condensation, risk of condensation in our walls. So we've got a risk, an obvious risk of water from the outside that comes in the form of rain. And in our perfect wall assembly here, we deal with that by providing a water control layer and a water shedding cladding. So our cladding sheds the water, and water that gets past the cladding reaches our water control layer and drains through that cavity, and we're fine. But we also have to contend with condensation, and we get condensation where we have cold surfaces and air that hits those cold surfaces. So I do not have a beer, but if I had a beer in my hand, we've got the cold beer, warm day phenomenon. You get condensation on your beer glass. There are only three things that you can do about condensation. One is to not have a cold surface. So drink warm beer. That's not fun. But that's an option. Drink Guinness. There you go. Make the surface warm and you don't have a condensation problem. The second approach to condensation is don't let air get to the cold surface. So instead of taking the beer out of the fridge, you go into the fridge to drink the beer. You're fine. No condensation. Also kind of weird and uncomfortable, but
it's cold.
At least, yes. And then the third way is to dehumidify. And that, for the most part, is not very practical for us. We can't dehumidify sufficiently to prevent condensation a lot of the times, although we sometimes do this. So usually when we're talking about condensation control in building design, what we're usually doing is we're trying to reduce cold surfaces, or we're trying to stop air from getting to those surfaces. So now let's go back to the perfect wall here. When we have our insulation on the outermost layer of our water control layer, our air control layer, and our water vapor control layer, what we're doing is we're keeping that layer warm. So in keeping that layer warm, we don't have the risk of condensation. So beautiful approach here. Our water control layer is going to be warm because it is on the warm side of the insulation. Okay, do I have a cursor? I do not. That's too bad. I guess you guys know where this is. So the bright pink, that layer is warm because it's on the warm side of the insulation, and it's most closely approximating the temperature of the interior. No condensation risk. We're great. No cold surface, no condensation. So now let's switch this same perfect wall to the summertime condition. Well, we have a cold surface now. Condensation is possible. We've got our fuchsia layer, our water control layer, our air control layer, and our water vapor control layer is going to be cold. It's going to more closely approximate the temperature of the interior. And our insulation is typically not, we haven't detailed it to be completely air impermeable. So we've got a condensation risk at that surface. But that surface is outside. So do we care? Our water control layer gets wet. We're outside, no problem. As long as we're draining our cavity, and this is a key part here, everything that's outboard of our water control layer needs to be able to tolerate wetting, right? So you wouldn't put a cladding on a building that was paper-faced gypsum. You wouldn't clad your building in that. Actually, and sometimes people forget that, right? They'll put paper-faced gypsum cladding, or gypsum board on soffits, balcony soffits. Well, it's outside. What's going to happen? It gets wet. So anything outboard of that layer needs to be tolerant of wetting. But in any case, the perfect wall works when we've got insulation on our outboard of our other control layers. So That is the perfect wall, but most walls are not the perfect wall. We increasingly are doing this, are kind of getting closer and closer to the perfect wall, especially in colder climates. But most of the time, we're not building that wall. We have constraints related to cost, constructability, and materials a lot of times. So a lot of times we don't see people using continuous exterior insulation, so that we're wanting to use cavity insulation instead. We might not be able to. It might. There's all kinds of reasons why we might depart from the perfect wall, but to others, we may have difficulty maintaining the continuity of our control layers. We need to account for structure, windows, and services, and these things go through this stuff. And depending on what our design is, that might be really difficult. So we have to either have the perfect wall in some places and break with it, or we never get there to begin with. And then finally, sometimes that perfect wall concept is not compatible with our aesthetic intent. So suppose we're building a precast building. We might not be insulating that precast building on the exterior. Maybe we're insulating it on the interior. Lots of people want to do these shipping container type things. They want them to look like shipping containers, so they're not insulating on the outside. There's all kinds of reasons why we may depart from the perfect wall. Usually these are related to cost and constructability though. But a lot of times it comes down to materials as well. Remember how we talked about everything outboard of the water control layer needs to be tolerant of moisture, of wetting? Well, what if we don't want to use an insulation that's tolerant of wetting outside? What if we wanted to use, and this is where a lot of people's preference for using non-foam based insulations starts becoming a driving factor in deviating from the perfect wall. You can't use cellulose by itself on the outside of a wall assembly, right? It's gonna get wet. You have to take that into account. You've got to find some other ways of protecting that. So here are 3 common deviations from the perfect wall, and I'm going to go through each one briefly, and then we'll get to the rest of the Sweet 16 proposals here. But the first one is the most common wall we have: standard cavity insulated wall. So we see this all over the country. You've got wood studs, fiberglass bats in between them. Your usually mechanically attached water and air control layer on the outside, and then some kind of cladding. That's super common to build this way still. This wall works in warm climates. It does not work in cold climates for a few different reasons, or we have risk in cold climates for a few different reasons. In warm climates, everything stays warm enough for us to, we're fine. We don't really have much of an issue. But in cold climates, where's our risk of condensation on this? Where are our cold surfaces? Our sheathing. The interior face of our exterior sheathing is going to be cold. So air, warm interior conditioned air that goes through bypasses our drywall, goes through our insulation, can condense on the backside of our exterior sheathing and cause excessive wetting. That wall gets wet, we have real problems with that. So that ends up being a risk. So we have to contend with that. That's the risk that we're contending with in colder climates. Next wall, cavity insulated wall with exterior insulation. So same as the standard cavity insulated wall, but we're adding exterior insulation to the outside. Again, we're adding that exterior insulation needs to be tolerant of wetting. But what have we done to that risk of condensation? Gone. If we keep that surface warm, our condensation risk is decreased. So we're in pretty good shape. So the cavity insulated wall on the exterior, that will work. That's really close to the perfect wall, right? Really close to it. The only real difference is that we're also insulating in the cavity. And so the danger here is in making sure that we have enough insulation on the exterior of that wall to keep the exterior sheathing warm enough so that we avoid this problem, the condensation issue. So if we're only using a little bit of insulation and we're trying to build in Alaska, we're going to have more of an issue. If it's only a little bit cold, you know, even a little bit of insulation will be just fine for us. So now let's move to a double stud type configuration. So let's say we don't want to use exterior insulations that are foam based. We want to use, for whatever reason, we want to use a moisture sensitive insulation on the exterior of our assemblies. So we essentially build, we've got our standard cavity wall. We put an air control layer in there first. And then we build a second wall, or hang some sort of structure, trusses or whatever, hang something off of that wall, and fill our second wall with cavity insulation. So where is our risk in this assembly? We're still keeping our exterior sheathing warm, where I'm showing the air control layer. We're keeping that warm. So we're good there. So we've got to be good at that. We've got to make sure that sort of mid-wall air barrier does its job, because we certainly don't want it, our outermost sheathing layer, that's cold. So we don't want interior air getting there. But if we're reasonably good at that interior air barrier, we're in pretty good shape, right? So that's the fuchsia dashed line mid-wall. That puts us in a really good position. Where is our risk in this wall? Our real risk is in keeping those the added section, that cavity, our risk is in keeping that dry enough. So we've got a really insulated wall there. So not a whole lot of energy flow across that. So what we really need to pay attention to is how good are we at controlling at our water control on the outside layer of our outermost layer of sheathing becomes really important to us. Really, really important to us. How well that's installed, how well that's detailed. Because if we get a little bit of water from the outside, not from the inside, from the outside. I mean, it matters from the inside too, but the more realistic case is that we get water from the outside into that cavity there, and we have no way of really drying it out because we have very little energy flow. We have so much insulation, it won't re-evaporate, it won't dry out. There's not enough energy flow. We're too effective at reducing the thermal flow there to have anything dry out. So we've got to be really good at water management with type of assembly. There are other things that we can do to reduce our risk in this, and we'll get into this when we get into the nitty gritty. But what we want to do is we want to be really, really good at water management on the exterior to make sure that we reduce the likelihood that we get outside water in that space. But let's say that we're not entirely perfect and we get water in that space. How can we maximize drying? What can we do? Well, we can use a sheathing material. The outermost layer of sheathing could be a material that's very vapor open. So instead of using OSB, we could use plywood. Instead of using plywood, we could use gypsum, Dense Glass Gold. And then whatever your outermost water control layer is should also be vapor open to maximize how much drying you get in that assembly. Now this becomes a big issue where it's cold. The milder the climate, the less that matters for us, because it's warmer, right? When it's cold, I mean, there is so little energy when it's cold, right? But when it's warmer, that matters a lot less. So that's kind of the basic rundown. I hope this helps talk about these proposed assemblies. A few of the things that you might want to think about, or that we are contending with when we're deciding what we want to build, apart from just the physics here, are our preference for I alluded to this before, our preference for one kind of material over another. There's all kinds of reasons why you might prefer something over something else. Availability, cost, whether you have a labor force in your market that's that understands that material and is capable of installing it and detailing it properly. Your own comfort level with that material or that assembly matters a great deal. It's not fun on my side, on the design side, if I'm speccing material that a contractor has never used before or is really hesitant about, that I don't want to bully my way into getting him to reluctantly accept my proposal. I might prefer to compromise a little on performance in order to use something that my contractor or my sub is more comfortable using. But people are really different with that, right? I'm on the design side. If I had more control over the building process, maybe I'd come down a little differently. I've got more control, and I know that I do a good job, and the people I work with are very attentive, and so that affects the decisions I make, and how I kind of contend between these competing values. But yeah, cost, constructability, comfort level, and then what your other constraints, what your owner likes, what your owner is willing to pay for. Some of these double stud walls, they're big, they're thick, that has a different look. There's an aesthetic implication to that. And some people love that, some people don't love it. Same thing with the one that our sort of middle option here, the cavity insulated wall with continuous exterior insulation. The insulation takes up space, so that can affect the depth of your facade, where you place your windows. Maybe you buck them out, maybe you have them more inset. All of these things come into play, and there isn't. I'm sorry to say to my dad, there's a conceptual perfect wall, but there's not a perfect one-size-fits-all wall, and that's why this competition has been really, really kind of fun and kind of neat. And with that, I'll turn it back over to Joe to talk about some of the specific contenders that we've got here.
Yeah, I thank you, Christine. That is awesome information, and I think a perfect overview of what we saw within the competition as well. We felt really grateful. This was like a small local Kansas City thing that we just kind of kicked up, and all of a sudden we have phenomenal builders from both coasts and architects and designers and people just from all over the place. So I think we saw everything from small local remodels, people just trying to learn, all the way up to the top. There's a couple of things I wanted to highlight. I think a lot of what you talked about was performance. A few themes that we saw through the whole competition. Carbon, how much of a factor is that? We had talks about incremental progress versus this ideal progress. We had, retrofits versus new construction. Something you touched on a lot is climate specific. The things that work in one area are just not going to work in other areas, or they might not work as well, or you might need to focus on different details. So I think that context is super important. What we really want to focus on today, I know we're wanting to get to the final. I know that everybody's starting to vote. Thank you, Travis, for getting that out there. If you want to vote in the chat, we'd love to have it. I believe it's only separated by 2 votes right now, if I'm not mistaken. So Joe Cook is carefully tabulating everything, and we'll be able to get the results here. But I want to encourage you not only to vote, but also questions for Christine. A lot of awesome information. Please, if you have any questions for her or for any of these great professionals, this is an awesome time to get it out there. We love this format, one of the benefits of everything going on right now. What we want to do is highlight, before we get to the very, closest we can get to perfect wall, I want to kind of acknowledge some of the limitations that Christine mentioned, your workforce, your budget. We're lucky to have Matt Blomquist here. And Matt is, I would say, as much of a pioneer as anyone else in this room. Basically, he touched on a little bit earlier. He's doing a construction program at a local high school. And Matt, I would love to have you say a few things, and I know Christine has questions for you too. Starting from a basic wall, wanting to do something.
I have lots of praise for you.
Yeah.
Nice wall.
Thank you.
I would love to hear, like, how did you go about saying, okay, I've got this basic wall, I want to start making some improvements. How do you start, slicing some of these options available and sort of decide where those incremental steps begin?
Yeah. Again, thanks guys for having me on and being part of this. This is great. So for, like Joe said, I took a high school group and we built a house. Well, almost built a house. I'm finishing by myself now, the inside, but the wall and the building envelope itself, I knew I had just seen Steve Basic's article and video combination, I think it was in Fine Home Building, with a passive house. And I thought that was really cool. And I was really impressed that they were doing things with simple, like acoustical caulking and stuff. I was like, oh, that's not too bad. Well, about the same time that was going on, I just happened to see Jake Bruton's article on air sealing in JLC. And then I started following Steve on Instagram, started following Jake, and all of a sudden I found out, oh, these guys do stuff together all the time. And Jake being in Columbia, Missouri, I went to college at Mizzou, so I was familiar with Columbia. I was only 3 hours away. I called Jake up and said, hey, can I come see what you're doing? I like how simple I like how simple you're making it for how high performance you're getting. I thought this was something I could handle, not only doing in my skill set, material-wise I could acquire here locally and easily, and also teach high school kids who have literally never built a house ever. We've done some framing and stuff in previous classes with me, but as far as building a house, this is our first time. So I was comfortable I could do that. So went over, met with Jake. He toured the houses with him. I think we went to two of them, his personal one and then the hybrid house. They were both at the framing stage, so they were great opportunities to see. Went to back to the build site, school kicked off, and it was kind of one of those things like, okay, this is what we're doing. And it is one of those things where also here where I live, like shutting down coal mines is a bad thing, like, because dad loses their job and now we have to sell the house and live in a different house that's not as nice, so, for us to jump all the way to, what Mike and Ben and these guys get to do, great. I know we're in different climate zones and stuff, but I mean, that's not that it's difficult what they're doing, and I could teach kids to do that, but the town, like the builders around here it's not gonna fly, So
take a step.
Yes. So for me, it was like, okay, it's easy to teach kids that know nothing. I can do that because their minds are moldable. They're not going to fight me on this. But what could I do?
It's in some ways easier. You've got an advantage. They haven't learned any bad habits.
Yeah, with the kids, it's super easy. So now we got 30 kids that they understand what air sealing is. They understand why we should do it. They understand why air brings moisture. They understand why we use acoustical caulk to do it, because it, if sound moves through air. So if air's not bringing in moisture, so that they get that. Plus that, as far as building goes, they could go work for any builder here in town. They know how to do simple framing. They knew how to put sheeting on. We went with the zip system, our panel, for our continuous insulation on the outside. I've never said continuous more in my life than I have this past year with continuous bead, continuous insulation. But they understand, that insulation's for thermal bridging. So it was one of those things. For me, it was the incremental thing. Putting a rain screen on the outside of the house. I don't know how many people got to text me or ask my fiance, hey, why is there strips on the outside of the house? Like rain screen. I think, I know that people have done rain screens in the past, but usually it was only to level out old farmhouses so that you could put your vinyl siding on and it was straight. That's as far as rain screening's ever happened. I have rain screening on the addition I'm sitting in at my house. because I read about it in Fine Home Building, and we have cedar siding on the house. So since we matched that, I was like, oh, I'm putting a rain screen on. That makes perfect sense. The rain screen is just 3/8 inch ripped plywood, AC plywood. So it's cheap, it's inexpensive. You know, with the windows, we didn't have to do any window bucks or nothing. We do have to do jam extensions on the inside of the house for trim work. But as far as building the house, it is built about as similar as anybody in town is building. Although I did just see somebody throw some brick up on a building that got repaired and there was no house wrap even on the OSB. So that could be a treat for somebody later down the road. But I mean, you know, we're definitely in a place where if I went to somebody and said, hey, you should go around the house 3 times with this extra insulation and furring strips and this and this and this and that, they're going to be like, no. Because when I was in business for myself, almost the first call you always got was, or actually when people call me now, hey, who do you recommend? Who's the cheapest? I'm like, I'm not giving you the cheapest. Like, so, you know, it's one of those things where it's kind of funny being in a rural community, you'd think they'd be more environmentally cautious, but really, you know, even with the farmers, it's how much chemicals can you pump in to get the biggest yield, you know? So it's definitely one of those things where it's almost always about the budget. You have those people who are conscious of the environment and things like that. But with this, you know, I can argue the point where building tight houses, that was another thing. No, a house has got to breathe. You know, everybody's heard that one. And so then I have to do that little preach with them. And so when Travis and Jake came up to the house and did blower door tests with us, when we were depressurizing the house, which by the way, the kids got the house built down to, I think it was a 0.53 or 0.58 depressurized as far as air sealing. So they did a really awesome job. We were not expecting to get that low. But when we were trying to get the smog out of the house from Jake's fogger, Travis and I opened up one of the 5-foot casement windows, and to see where it'd get to be code for 3 air exchanges, I think that window had to be open like 2 full inches. So now I can tell people, and I did a little thing for the teachers at the school to tell them what the kids had done. I was like, here's what all these numbers mean. You know, they don't know what 0.58 means, ACH 50 and 3 and all that stuff. So I said, what we did, I said, code is if you open your window, a 5-foot window, 2 inches, leave it open all the time, your house is code for where we live. And then people are like, well, that's stupid, you know, like nobody wants, you know, we have kids, we always tell the kids, shut the door, we're not heating the outside, right? So, you know, that became a very easy item to pitch. And so now I get questions about that, you know, people asking, oh, well, so what do you have to do to, tighten up a house or this and that? So, you know, like I said, it's baby steps. The good thing is we've done this one. So now it's, you know, what do we do with the next one kind of thing. And it is definitely a progression, and it's been fun, and the kids did awesome.
So a little bit of extra context there. You mentioned a few things that I think it helps to have a little context. When we're talking about energy efficiency specifically, so there's all kinds of other performance metrics that we care about, durability, you know, there's all comfort, acoustic performance, whatever. But when it comes specifically to energy efficiency and energy performance, it's kind of interesting, maybe not super intuitive, the sort of priority of factors, of design factors that actually influence that. The number one most influential or number one contributor to how efficient an enclosure, energy efficient an enclosure will be, is the glazing ratio. So how much of the enclosure is glass, and what kind of glass is it? That is the number one biggest contributor to energy use. The second is how airtight is the enclosure. How good are we at keeping continuity of our air control layer and keeping the inside air in and the outside air out? And then the third one is insulation. And you know, what is the thermal resistance of our assembly? But it's kind of interesting that it's in that order. That a lot of times we think, well, insulation should be the most important because that's the one that has to do with energy. But realistically, when we're dealing with real enclosures, it's glazing, air tightness, and then insulation. Now, all of them are important, all of them. But what tends to be the lowest hanging fruit for us from a practical perspective is air tightness. Air tightness gets us from being from being like really terrible to extraordinarily good in one step. Now, again, you don't want to waste all of your savings by making, using enormous glass and single pane crappy stuff. You obviously don't want to squander the benefits, but glazing, air tightness, insulation in that order. So
Yeah,
it's kind of interesting.
And for windows, we stepped up and went with Marvin. They were Marvin. Oh, I forget what they branded now, but they're triple glazed. We went with casements for ceiling. Nice windows. Around here you're going to see a lot of Anderson and Pella brands.
Even windows too. A lot of the air tightness numbers can be really hard to reach if you're using windows that themselves leak. My windows, you're not going to be able to see them, but the window next to me, I don't know if you could, I can push it, you can hear it. It rattles in the wind. Like when the air comes through that. So you guys are already a big step ahead. Who's next?
Yeah.
I wanted to get Mike on before we left.
Thank you, Matt. That's awesome.
You're welcome. Hey, thanks, guys.
No, we're glad to have you. We appreciate the work you're doing. I know we're about to lose Mike, so we're gonna kick over to Mike pretty quickly. I guess, Christine, did you have any specific questions to Mike? I've got one here, but.
Sure. I mean, so Mike's approach is, I've got two comments. I hope you have enough time to address them, but one is Mike is doing this. It's not a double stud. It's not quite a double stud wall, but it's the same sort of approach. He's using moisture sensitive insulation outboard of a wall, and he's controlling. He's what are your provisions for keeping that dry? Number one, and then number two, I thought it would be interesting if you had any thoughts to share on the modular aspect of your proposed wall.
Yeah, no,
because I love it.
Yeah, no, it's an excellent wall, and just I feel a little funny because I was one of the last ones to submit. I often do thinner assemblies, but my favorite is the EcoCore system, and we happen to have Chris Corson here who actually developed the system, so I feel a little weird talking about it with him here, but
I can just sit here and drink. I don't have to do anything.
Yeah, there you go. Well, just because it's been, you guys have had 5 years of development since I worked there, and I'm sure some things have changed, but essentially it is the Stebrick perfect wall. It's a framed wall with an airtight zip sheathing as a vapor retarder and air WRB and air control layer, which creates a surface cavity on the interior and provides for all the connections. And that can be insulated, but there's so much insulation on the exterior that the insulating the cavity is just sort of a bonus. The top photo there with the blue membrane was the first, or one of the first projects I did when we worked there. They've actually changed the product color, so that's what Proclima Mento used to be blue. Now it's black. On the bottom model is the current black color, and just Chris's system is just its belt and suspenders, and another pair of suspenders is how I've heard him describe it. The zip is taped, the penetrate, any penetrations are taped, then the TJIs are screwed to the outside. There are a lot of comments in the competition about the thermal bridging through the TJIs, which are wood eye joists. But the fact is, because they're 24 on center and 11 and 7/8 inches deep, and they're only, they're OSB, 3/8 to a ½ inch thick, there's virtually no thermal bridging. The total, it affects the total R value by less than it was like 2%, I think, difference in R value. So Passive Us considers it thermal bridge free. On the exterior of the TJIs is Proclima Solitex Mento Plus, which is a monolithic membrane that's super tough, very vapor permeable. It's either 30 or 38 perms. I think it's 30 perms, and it can withstand a 38-foot water column, which is just insanely water resistant. And then there's cellulose dense pack behind there with cross strapping on the exterior.
So yeah, talk about what comes after the water control layer, the vapor open water control layer that you've got there, the black.
Yeah.
You've got cross. So first of all, that's spanned unsupported. I mean, it's supported by the cellulose, but you're not using a rigid sheathing product. It's thick enough that it stands up on its own. Really, that doesn't get punctured.
The Mento, you mean, Christine?
Mm-hmm. Yep.
Yeah. Well, it's basically, just think of it as Tyvek, but about 10 times as good as Tyvek. But it's a membrane. Tyvek isn't really waterproof. It's hard to keep it. It's an entry level.
Hard to keep it intact.
Yeah, exactly. And Mento is you can literally support your entire body weight on it. So the Mento is applied, it's taped, so the Mento is also airtight and watertight. And then on the outside of that, to provide a three-dimensional rain screen gap, it's vertically strapped over each of the TJIs. And then, which are 24 on center, then in between those, there's another vertical layer that helps, because when you dense pack it, the Mento basically wants to push out a little bit. And then it's cross-strapped horizontally. That works really well for vertical siding. When it's horizontal siding, it's a slightly different approach. But it's basically two layers of strapping, which in New England is 1x3 low-grade spruce. So it's basically practically a waste product. Very low carbon, very simple, fast install. And the key to all this is Chris has a very high-tech panelizing facility. So this is all made on Swedish style platform framing tables, so it's all built on the flat, and they have keys that basically keep everything in place, and everything is modeled in a computer and cut with computer controlled equipment. And just it really 5 years ago I saw how fast it went together, and I'm sure it's much faster now even, and precise, and yeah. Did I miss anything, Chris?
No, do you mind if I just jump in for just a second to answer one of Christine's questions?
Yeah.
So the Mento Plus that you show in your picture, Christine, is this particular product is fiber reinforced. It's a totally monolithic, it's a fleece essentially. And we use that fiber reinforced product because we're insulating the 12-inch insulation cavity to about 4 to 4.1, 4.2 pounds per cubic foot, so that cellulose is ensured that it stays stable in that environment. Mike's right about the battens and counter battens. The Mento Plus has a permeance of about 38 and is waterproof to about a 8-foot water column. There are other fabrics that we use that are waterproof to a 32-foot water column, which is,
So honestly, I don't, I tend not to care as much about the water column metric, because I think it's a little bit of an unfair, I mean, not that it doesn't matter. You have to test things in that way when you're in a laboratory looking at assessing your own materials. They have to do these tests, fine. But in practice, the real risk here isn't so much the water column. It's am I going to get water that if I can physically keep this membrane intact, is if it's robust enough that I'm not going to tear it up during installation, right? If you were using, say, instead of this, if you were using a felt paper, also fairly vapor open, right? What would happen to that? It just, you can't maintain the continuity. It's just not, you can't do that with something that's
destroyed.
easy. Exactly. So is it actually going to be continuous, and are you going to keep rainwater outside of this wall at your service penetrations, your joints, your panel joints. So you've got a panel system that fits together, so you've got a good way of handling that. But at your windows, this is to put some context in it, and I don't mean this as a criticism, but this is because it's so insulated, this is a much less forgiving assembly than the previous assembly. Now, that doesn't mean you shouldn't do it. Anytime you use more insulation, you're doing exactly what the insulation is designed to do. You're reducing the energy flow, which means that you're increasing risk. So you end up having to take a step up in terms of attentiveness to all of your other detailing. So you can't be like a 101 window installer on a wall like this. Now, you shouldn't do that anyway. You should be attentive on all of your windows, but everything matters on this. And hire really good people like our friend Michael Maines to put this stuff or Ben Bogey to put this stuff together. This is not this isn't a let's just go see if we can figure this out and pick some people up at the Home Depot parking lot and see if they'll do this for us.
Yeah, Christine, I just want to say one thing. I remember being on one of your dad's job sites one time, and he was saying how some walls just need more adult supervision in order to build.
Exactly. Although I bet some of these Matt's high school kids, I bet you they could do this.
I guarantee they could do it.
I think I'm really interested in panelization. Like I taught at a prison before this, and we built wall panels for Habitat for Humanity. So now I know a little bit more about air sealing and stuff. I think we could do it. We could do it.
We could totally do it. So, I mean, it's hard. I don't know who's talking because Mike's doing a screen share, so I can't see anybody. So if I've interrupted, I apologize in advance. I will say that, like, I welcome the conversation, Christine, and your criticisms are exactly on point. Like, it is a complicated wall assembly, and it does need to be assembled properly, not only in the factory, but in the field as well. And if there's a detriment to the wall assembly, I would say that that's probably it. 5 years ago, or, well, 10 years ago, thought it was a perfecter wall. But as I have gotten older, I have softened my stance on that as well, right? So there's a middle ground as we grow, and eventually I was a young dude who didn't know shit, and now I'm starting to be an old dude who knows some stuff. So that being said, you know, this wall wasn't designed to be the most cost-effective wall. I think that and the complexity of it are probably the downsides. It was designed to be the best performing wall for our climate, which is, you know, minimum 7,500 heating degree days up to like 9,000 heating degree days, right? So that's the range that we live in for this assembly. But it was designed to be the most thermally effective wall with the lowest embodied energy, the lowest cradle-to-cradle costs, and the lowest VOCs that we could put together at the same time trying to make it a product that could be assembled by local tradesmen without it being outside of the business as usual approach so far that they couldn't do it, right? I think I'd rather take 5 of Matt's kids than 5 seasoned carpenters from Jackson Hole, Wyoming, like any day. You know, we get complacent as we get older and we do things the way we've always done them, and we don't want to deviate from that.
And I mean, you're highlighting a really good kind of tension there that it reflects what you value. So the issue with double stud type assemblies, I know this isn't quite, it's a variation of a double stud assembly, but the issue with those are increased risk from using moisture sensitive materials outside of an enclosure, complication and constructability concerns. like it's more constructability, and then less forgiveness in the assembly should you make a mistake. So this category of wall deals with those three sort of risk features. So how you respond to that is going to depend on what you value. Number one, how much do you care, or do you care about using, or about not usually it's about not using foam insulations on the outside of your enclosure. If you don't care about that, the risk is probably not going to be worth it to you. If you care a great deal about that, you're going to say, oh, you're highly motivated to take another look. Okay, well, what can we do to reduce that risk? And this assembly uses panelization to reduce the risk, right? And material choice. So you're selecting certain kinds of materials that are pretty robust. You're using something very vapor open on the exterior to maximize exterior drying, and you're being very, very good at all of your detailing. So that's how you're in response to the goals. You're addressing those risk factors by intelligent material choice, panelization, and smart and attentive detailing. And that's a perfectly appropriate response to dealing with risk.
Hey, Chris,
Sorry.
Chris, well, I want to give, because Christine just kind of summarized it a little bit. I'd love to hear from Ben to get some ideas on how he kind of addressed those same things. I also, and I'm sorry to cut across you, I know that Mike has to jump out. So I think we're going to extend voting so that Ben can have a chance to kind of make the same case. And then if you'll stick around for a little more dialogue, we can, I guess, text Mike if he wins or not.
So I'd love to stick around and have this conversation. It's interesting to me. I have to apologize. I'm not familiar with Ben's wall. So like, Mike, before you leave, do you have in your PowerPoint or Instagram, like parallax, like something that I can just look at Ben's walls real quick? Or can
I got it.
Yeah, Travis. So if we want to
thanks a lot, guys. I'm really sorry I have to run, but I can't tell time, so I have to go. But
okay. Thanks, Mike.
Thanks,
good
Mike.
luck.
We appreciate your time, and we would send anyone who sticks around for the end of this over to Nathan's meeting where Mike's headed to present Pretty Good House.
All right.
Very cool.
See ya.
Thanks, Mike. So yeah, let's kick it over to Ben and Travis. If you have, even if you have other images as well, if you're willing to share. And Ben, do you want to just kind of dive in on some of the strengths and weaknesses Christine already laid out?
Yeah, we could kind of, sorry, my Zoom kind of glitched out for a moment there as Mike exited the room. So I was just kind of getting my screens back to where they belong here.
And Ben, if you have your SketchUp
yeah,
display,
we can go at this, however,
go ahead.
Yeah, I was actually going to offer, I can do screen share. We can kind of look at my wall assembly in 3D if we have points that we want to look at here.
So much better in SketchUp than what I had. I had to screenshot that from yours. So I want to do you justice.
I mean, it's a double stud wall.
Yes.
Yeah. I mean, it's
a double stud wall. Yeah.
What's the exterior?
All right, are you guys seeing it?
We see. Beautiful.
All right. So here we go. So basically, this current iteration that we're working on right now, and you can go over to Find Home Building or pick up your most recent copy, Chris, and you'll see a whole feature on this wall. Shameless plug. The exterior sheathing here, we're using CDX. We're using half-inch CDX here to keep as much vapor permeability as possible. We're Siga MyVest SA, fully adhered, WRB on the outside with a 3/4 inch rain screen. It's hard. This is like the toughest wall to go up against is you and Mike's wall here for me, because if I had to choose a wall assembly to build, it would probably be your wall assembly from a performance standpoint.
Voting's over.
Actually built your wall assembly in the past. Yeah, no. I'm being totally honest here.
I appreciate that.
Pros and cons as I see it. I built that wall maybe with Siga instead of Proclima on the outside a couple of times. So performance-wise, your wall is very good. The problem that I have with your assembly, and the reason that we go with the double stud assembly is it's the exterior I-joists or Larson trusses or however you want to address it, it's too many trips around the building and it's too much labor for us to stay competitive in our market. So we're trying much performance as possible.
Sorry, Ben,
So
you're breaking
that's why
up a
we're
little
double
bit. I don't know
so
if it's...
we can just here, let me try. You guys got me back now?
You're back.
I'm back. I'm going to close out screen sharing because I think that was just hogging some bandwidth for me. So I don't know where you guys lost me. The biggest issue we stick with double studies is because we can keep it cost competitive enough that we can still deliver an incredibly high performance envelope without having to have a really niche client. You know, we have clients coming to us expecting, you know, an above board level of performance, but we're probably not getting the type of clients that are searching Chris and EcoCore out. So we're getting clients that are coming to us wanting something better than normal, not knowing what that is. And we're using this assembly mostly in order to deliver a really robust envelope, but without scaring them off on the price. So we do have to scale back oftentimes on some things like interior finishes, cabinet choices, flooring choices, and it's a balancing act for us in those regards.
Now, I think I would be remiss if I didn't highlight for people, because some people, this is really the first time that they're seeing double stud walls, or I don't know how you would categorize, Chris, your wall. If there's a term for it, I would love to hear it. Or anybody in the comments. Like, the concept is that you're using, or the concept I'd like to describe is using a moisture sensitive insulation outboard of your structure and protecting it as a result. But anyway,
I've always categorized it as a hybrid box beam version of a persist wall or something like that. So it's exterior insulation.
Well, that's not a catchy name. Come on, marketing. let's come up with something. But yeah. Anyway, I'd be remiss if I didn't point this out at least. One of the constraints of this is floor area. These walls are thick. So you've got to be in a spot where, so suppose you're in a place where you've got very tight lot lines or tight restrictions. You're going to sacrifice. You're either going to have to, if you're someplace where you've got plenty of room, you're going to expand your footprint, which has cost and size implications to it, although not enormous, but that you pay attention to that. Or you're going to sacrifice room on the inside. Now that a lot of places that is not going to matter. It's not going to be a factor in the decision, but some places that is going to be a factor in your decision. Just pointing it out.
No, that's exactly true. And I mean, this wall assembly originally was focused towards single family, custom, and model home residential construction.
Yeah, plenty of people have the room for this. Plenty of people, but not everybody does.
If this is a contest, it's a contest between this and a double stud wall, which I think the differences between the two are worth talking about. And that was one of the things that I was hoping to speak to before Ben started speaking. And Ben, I don't want to take any time away from you, so I'll be as brief as possible. I built my first double stud wall in 2001. There are advantages and disadvantages to both. I think from a building science standpoint, exterior sheeting, whether it's zip sheeting or OSB or CDX, is less vapor permeable, and I think there's a propensity for potential condensation within the wall assembly to accumulate over a period of time because it is not vapor open.
Stop right there for a second.
Yeah.
Yes, that's true. That is a risk, and one way that you can modify. So if you're wanting to take a step in the less risky direction on Ben's wall,
gypsum sheathing.
Use gypsum, use dense glass, or use plywood. On your wall, I'd still use sheathing. I like that. One thing I like about your wall that I don't like as much about Chris's wall, but I'm also conservative because I don't have experience with this product, is I like having a rigid sheathing outboard on yours because it's rigid. I can detail it well, I can protect it well, and the integrity of that water control layer really matters. So I like that yours has a rigid sheathing.
Yeah. So let me speak to a couple of points here. So first off, just to pick up where you're going, Christine, that's my concern with Chris's style of walls is we're talking on a 100-year time scale. How durable is that PPE or TEE monolithic film gonna be over 100 years if the cable guy comes to move service, or some chipmunks decide to find their way up into that range?
We won't have cable or chipmunks in the future.
There's no cable in 100 years.
Those cable guys are going to have to find a job. Those drills are going to get dusty and need to do something. But you know what I'm saying? That's really my only concern. That's fully honest, and I'll admit the deficiencies in our wall system too. There is the concern, there has always been brought up the concern of the condensation inside of the wall assembly. And I know some of you guys know this about us, but we go as far as to bury monitors into our wall systems and have been for a number of years now in the worst case possible scenarios on our buildings to try and see what they're doing. And so far, we have yet to see anything that's swinging into the danger zone.
So
I think that is a benefit.
One more jump in there to help kind of clarify some people who are less familiar with your system. So the risk here is we're dealing with two sources of risk. One is condensed moisture from interior activities, interior generated moisture, breathing, cooking, cleaning. And we want to stop that warm moisture air from reaching the outermost layer of that assembly that's really cold. For that reason, Ben has to be really good at how well he's detailing his interior control layer. It just says my internet is unstable. Can you guys still hear me okay?
No, you're
I'm good? Okay. So the integrity of that interior layer, it matters a lot. You gotta be a professional when you're detailing that. The second source of risk, and this is the one that I think we pay so much attention to the interior air and vapor control layer that we forget this. The bigger risk is the exterior. In any of these double stud walls or similar, the biggest risk is exterior. It's rainwater. And small defects become a big deal because once they're in, they can't dry outward. So it's not just Ben said condensation. He's absolutely right, because you have to contend with condensation from interior moisture leaking out, but defects in that outer layer they're very, very hard to dry out in these super insulated assemblies. Now, my wall leaks all the time, but it's really poorly insulated and it dries out. If Ben's wall had even a 10th of the leaking that I have in my wall, I have a 100-year wall that's crappy. It would cause problems in Ben's wall. Line. And so that's why that outer layer matters a lot. And so Ben is, just a moment ago, his preference for using something rigid because it facilitates detailing, because you've got something that's well supported to seal to, and future interventions in the house, which is a good point that you made earlier. But it's keep it. We get so, I think because people don't understand, and it's hard. It's less intuitive. Condensation and diffusion and that kind of stuff it's confusing for a lot of us. So we put the most attention on the thing that we think is hardest, but really rain.
That's why professionals should be designing walls, not amateurs.
Exactly. And we've probably all had the experience where people who really get into this, like we're really into this. We meet other people who think that they're really into this, and they're like, well, so tell me about, they get really excited about hemp and straw bale and all this stuff. I'm like, okay, that's all great, guys, but you gotta crawl before you can walk.
I'm just going to jump into a
different.
pile of mushrooms and just live there forever.
Right, exactly. I mean, people get really excited about this stuff, but you've got to, these are things that when you're going to the trouble to do all this stuff, you can't let your enthusiasm for the performance, the added performance, overtake the sort of sobering conversation that you have to have about risk, and contend with the risk factor stuff too. You've got to be at a Ben Bogey level of care and craftsmanship to do either of the top two contenders need a real level of care, and that's not a criticism, it's praise, really. And the reason these people, you too, both of you and others, put level of care into the walls is because they care a great deal about it. But these things have to go together. You can't have one without the other.
I think that's true, and I think that the drop.
You guys are too nice to each other.
Okay, so the driver, so having built several stud walls in my life, the driver for this wall assembly, first and foremost, originally was passive house, thermal bridge free, proper levels of insulation, and achieving the passive house metric. So there's a consideration for performance there that I think is critical relative to a double stud wall that can be adjusted for levels of insulation and the wall assembly, that external vapor permeable insulation, whatever it is. That being said, I agree with the wetting potential of the cladding, which is why we have 2 layers of the 3/4 inch strapping, which creates not only a drainage plane, but a convection plane. So it virtually eliminates vapor drive through the siding. Vapor is driven into that cavity and dispersed into the atmosphere before it ever even really.
Yeah, again, a great feature, but it's again not so much vapor drive. It's how well are you? It's bulk water, point loads. Yeah. How well are you detailing your windows? Which I presume to be very well, because you're very good at what you do. But the risk isn't so much in your assembly, is not with vapor drive. Because you've dealt with it. The risk is screwing up your detailing.
That's true, but that's true. I think that's true of any windows that are being installed in the punched opening.
No,
right?
It is more true for you. You can screw up. In fact, people do screw up windows a lot. A lot. And it ends up, we don't know about the screw ups because we don't look into the walls. We don't see and they dry out. But when you have because you're so good, because you're so insulated, even a small screw up of water in that assembly means your wall starts to rot faster. So it has real consequences, but you contend with that by detailing, doing a good job.
So something that I've got to chime in and say here is when I first really started getting into high performance building, I was fascinated by the passive house level and all the performance and those bells and whistles, and I still love that part of this field. But as I get older and dive into this more and more, the more I realize exactly what Christine's saying. Water management is what we have to be critical on, and it's what I obsess over nowadays. I can, the $10 or $15 or $20 or $100 for to save a client by adding another 4 inches of insulation on a yearly basis doesn't do it for me anymore. Because if we're not getting our water management correct, then it doesn't matter. So that's one of the reasons I prefer rigid sheathing on this. And just to kind of back up a little bit to what I was saying about monitoring before, one of the reasons that I think we're not seeing these prospective failures like Woofy tells us that we're supposed to be seeing in our double stud wall things, we have a 3/4 inch ventilated rain screen on the outside that we make sure is cross communicated just like Chris's. And that's allowing us to dry any of this vapor load that we see happening inside of the wall. Exactly this.
Oh
no. So cellulose insulation has the ability to, my internet connection is unstable. Do you guys still have? Have me?
You're kind of cutting out.
So we're using cellulose insulation, which is allowing vapor load to move into the wall and be redistributed and dry better. When we went to publish the Fine Home Building article, I was honestly a little bit hesitant to put this wall assembly out in front of the masses, because if you don't understand all the moving parts, it can be a risky assembly.
I mean, this wall assembly's been around for a long time.
Actually, that's true. If anything, we're better poised to deal with the risk because we have more materials available to us to help us
better materials, yeah,
detail our connections better.
Yeah.
But the connections really, the more insulation you've got, the winging it on window installation doesn't cut it. And also picking windows, buying windows that are commensurate with the assembly and the care that you're putting into the walls, right? I started my career working for Chris Benedict in New York City, and she was achieving passive house standards with using really crappy windows. It was amazing. She was very good at doing a lot with a little. Well, I wouldn't want to put a crappy window into either one of these walls. You gotta match. If you're gonna step it up in one area, you gotta step it up in another.
That's true, but Chris is building a lot bigger buildings with a lot less insulation.
That's true, and actually, there's also we're also speaking about residences here. So, and I'm presuming that in both cases we're dealing with overhangs, we're dealing with good, appropriate. No, not on yours. Come on, throw me a bone here. Okay,
overhangs gone. We use them. They're bolt-on additions to the assembly.
That's okay. That's fine.
Yeah.
As long as it greatly affects how much your wall's exposure to wind-driven rain is greatly affected by overhangs. It changes the wind pattern.
So,
1 story or 2 stories also substantially less risky than flat faces, way tall.
no, flat faces are good. Flat face is good.
Yeah, all right.
So I want to.
If someone wants to do something modern, no overhangs, super flat look. I would not recommend either one of your walls.
That's what drip edge is for.
We need more than a drip edge, but yeah, keeping 1 or 2 stories substantially reduces your risk. Versus building taller. Context here matters. When we're talking about residences and good water management on your facade, it's not just how you detail your water control layer. It's all kinds of other features.
So I just wanted, this has nothing to do, and if anyone wants to dip out, that's fine. But this is a really interesting conversation for me, and this has nothing to do with the competition or anything else. I just like to measure shit. That's like what I do.
Hey,
so
Chris,
Ben had mentioned like.
Chris, are you about to ask that question right now?
What question?
What I want to do is put a bow on things so that people can dip out if they want to, and then we got another little bit to stick around if you want to get farther into it. But I do have one quick question. I'm curious, like maybe 2-3 word answer. What climate zones, if you're able to execute this and you're able to design it and you're able to do all these things, what climate zones would you feel comfortable implementing these walls?
For me?
For you, Chris, and for you, Ben.
5A through 8 in various places. I think we're about to launch several new wall assemblies that will cater to other climate zones.
You could do it in a warmer climate. I don't know that you would want to.
You could. It just the cost efficacy just goes like through the floor. But yeah, my wall assembly will work from Florida to Maine, but it's not going to be cost effective in anywhere from Pennsylvania south.
Okay, Ben.
I'd take mine all the way right from the equator up to about zone 8 if I'm allowed to make some minor adjustments.
equator to 8. Because one thing that I think is really
Equator? How are you going to get your wall assembly to the equator?
I don't know. They have boats and stuff, right?
Unicorn.
You build it,
fairy
and then we'll
dust.
ship it down there. Yeah.
There you go.
Equator. All right, I'll go from the North Pole to the South Pole.
Yeah. So I think something that's really interesting, when we laid out this competition, this was all credit to Travis, there were absolutely no requirements or expectations, but as far as like what climate zone, what, influence of carbon, constructability, like none of this stuff was put out there. It was just like, submit some walls, anybody who wants to. And then it was literally open for anybody to vote on. And that includes, guys like Steve and Jake who were promoting it pretty aggressively on Instagram. And we ended up with 2 more or less, I trust Christine's expertise, more or less double stud construction from the state of Maine. So I think that really says something about the work that you guys are doing and just how grateful we are to have both of you here to kind of dig into some of these issues. Like Chris, I cut you off and I feel terrible because I've actually never met you before. And now I'm being rude to you, but you guys are getting into issues that are super specific to your walls, but I think are also applicable to guys like Matt, guys like myself, Travis, the rest of us that are just trying to build, in our Kansas City market, we're just trying to build the best thing people will let us, the best thing people will pay for. So I think it's really a tribute to you guys for building that market, for making that market what it is. And we're just really grateful to draw on your experience today. So I don't know, I'm sure Maine has some kind of motto, but I don't know it. So,
I mean, thanks for saying that, Joe.
I lead.
Forza Maine, is that what you said?
It's Dirigo. It means I lead. The Maine state motto.
I love it. Now I know.
So that being said, I actually built my first double stud wall in Florida in 2001 and my first straw bale home in Florida in 1997. So it's all about the things that Christine outlined, like dedicated control layers, water management, air management, and heat management. So it doesn't matter where you're doing or where you're building anything, you just have to find the right solutions and right size them for the particular situation. And it's always going to come down to detailing, whether it's installing windows or nailing on sheathing. If you nail on sheathing at 16 inches OC across the entire panel and around the perimeter, like there's a potential for the structural component to fail. So it's all about implementation and creating an environment that hopefully elevates best practices to a level that evolves, like somewhere sooner than 1942 to 2019.
On that, Joe, Travis, do you guys have the vote?
We've got a final tally. Joe, do you want to announce that?
Oh, go ahead, Travis.
All right, man. So we had on Instagram, we had 13 to 11 bogey over Maine's. We opened the chat box at 4. And it bumped up to 14 to 17 in favor of Chris and Mike's assembly. And then Ben got one more vote in the chat box since then, since he was allowed to present. So it's 15 for Ben and 17 for the EcoCore wall.
Dang.
Yeah, it's a tight race. I think that the real winners here are the Instagram community and the people that were on this call that got to actually hear Christine's breakdown, to hear the building science spread far and wide. So the real winners, they don't get the belt, but they get the education. And that's why.
Is there a real belt, or is that a digital
totally
thing?
A belt.
There's a real belt.
It's a legit belt. I'm shipping it.
Travis found it on Amazon.
That's the belt right there.
I thought you might have photoshopped that. That's the
I'll
real
go
belt.
get it.
That's a thing.
I will. I'll go get it right now. I will model it while we have a little victory speech, maybe.
I mean, that may fit around Mike's waist, but it sure as hell's not going to fit around mine.
I'll be right back with the belt. You guys got to carry the show.
All right.
So I got to say, I gotta say, I gotta take a little jab here. I'm amazed that I got this far with by far the worst description of any of the wall assemblies in there. I sent this to Travis when I was in the middle of managing about a dozen subcontractors on the job site and gave him about 4 sentences of stupid little things on the wall, and I made it all the way here.
I didn't even know this competition existed until Mike emailed me like a week ago.
Hey, you won.
So, I mean, that being said, that's great. I just want to say one thing to Matt. When you were speaking about the airtightness relative to the students that you were working with, I just did some really quick back of the napkin math. And so assuming a 2,000 square foot house with 8-foot ceilings using ACH 50 with a 2-inch opening and a 3050 window, I'm calculating about 1.74 ACH 50, which would probably be about half of what you'd be looking at for code at 3.25 or something like that. So I think it's actually, it might be closer to a 3 and 7/8 to 4-inch opening in that window. Just throwing that out there for future reference.
Yeah, well, and so I think our we were 1,600 square feet, and this was very unscientifically done. Like, in fact, all we did, Travis and I did, was just opened up a window and watched the gauge drop until it hit 3. So yeah, you're probably, and just telling anybody they have to open up a 5-foot window 2 inches and leave it open is enough to scare them. So but I appreciate those stats because I'm learning. Like, I'm not somebody I can't do that math and stuff yet. Like, as long as the gauge tells me and I dial everything right. In fact, when I first did the blower door test with one of my students, we did a trial run because we actually bought a Retrotech blower door kit for the program. And I was like, no way. It was like, we didn't have something, the square footage I didn't get typed in correct. I was like 100 square feet off, whatever. But we're still like hitting right around 1 and below 1. I was like, no way, we messed it up. We did something wrong. There's no way. Well, then, Jake came up and did it, and I was like, all right, we did it. So I still have to test it another time because we still had plumbing penetrations to put in and our recessed lighting. But the good thing is, like I told the kids, doing it at that point, now I know exactly where to go to look if we have any changes and stuff. So we'll do a couple more. And the nice thing is I have the school bought the kit for us. And so every build we do from here on out, we can test, I would say, no less than 3 times each, with each one. The kids get to see how Jake walked the kids through step by step how to do it. And then they went around with the thermal imaging gun and smoke machine and crawled up in the attic and the crawl space and looked for leaks. And it was awesome. It was a cool experience. And
these are high school kids?
What?
These are high school kids?
High school kids, yep.
That's
all right, well, if they want to move to Maine, give them my phone number.
Well, dude, I tell you what,
I just
go ahead.
I've got to chime in here for a second. So Mike Maines and I and Chris, I don't know if Mike filled you in on this, but Mike and I had a little conversation before this evening. Mike and I actually decided that we're going to call the competition a draw, and we're going to have the belt shipped to Matt, just as a thank you for what you're doing and pushing forward the good practices. And,
yes, way to go! I love that.
Educating the next generation.
Well, that is very cool of you guys. The kids will. I'll have to go drive by all their houses and let them take a look and get pictures of them or something. That's awesome. You know what? I got to tell you, you guys, the support. Definitely Steve and Jake have been huge with us. In fact, Steve's working with the kids right now. We have working through planning the next house with them. Like he was going to come here and talk to the kids, and I know he's not on here anymore. I don't think he's on here anymore, but he as soon as we went to quarantine, he's like, hey, can we just do a Zoom thing? And I'll still work with the kids on planning, helping them, he's walking them through the steps of planning a house, what to think about and stuff like that. So, the kids are getting almost a college level education with stuff and all the things you guys have done and learning from you guys. I mean, this wall assembly contest needs to be turned into a PDF file and turned into some kind, you guys you make my job easy. You guys create teacher content so well. All I have to do is copy and paste. Like, it's appreciate it. It's awesome.
I went to college, Matt, and those kids are getting something way better.
Oh yeah, I went to college too. I agree.
They're getting a professional education.
Yeah. PhD level.
For sure. Well, I think on that, I think we did it. Christine, thank you so much. Chris,
Thanks, guys. This was fun.
Yeah, thank you.
Thank you, Matt. Thank you, Rob. Thank you, Joe. Travis, do you have anything to send us home with?
Just the same note of tremendous gratitude for everyone who participated. It really did start out as an idea of how can we get people excited about talking through these details at our live meetings. And then when it opened up to Instagram, being able to pick the brains of a Ben Bogey, a Chris Corson, a Mike Maines, a Christine Williamson, that's a massive leap forward in the understanding of everyone in our local discussion group. And then being able to share that and disseminate that building science knowledge with people nationally is, that's the gift that keeps on giving, right?
And I'll plug Travis because he probably won't. You're doing a GBA article on all of this, so
it's already up. The Sweet 16 article Brian put up a couple Sundays ago, but I think this is sort of the follow-up. This video that Rob has graciously hosted for us through Fine Home Building, I think, is going to be the follow-up to it. So, Christine, I hope that doesn't mess you up for sharing your content. I know that's a great presentation that you've got. If there's any issues with that, please be clear about that. But we definitely, okay. Well, we definitely have been really fortunate to have partnerships with Rob and Fine Home Building and Green Building Advisor. And so that information's there on Green Building Advisor now for the whole competition. And then I think, Joe, you're plugging my work in progress. So I'll talk more about that later. That's not what this is about. Thanks, brother.
Can I say something? Do you mind?
Please.
So when I was in architecture school in the early 90s in Chicago, all I wanted to do was build shit. Like, that's what I wanted to do. I wanted to draw pretty shit, but I wanted to build stuff. And I never, at that time and up until even including this last decade throughout my entire career, I never envisioned having this conversation in this format with a bunch of sentient, intelligent, like-minded, and focused people. And I think it's a testament to you guys and everything that you're doing. I'm eternally grateful. And I think the platform that you've created through this BS and Beer Zoom online experience, albeit a product of our current social situation, I think is fantastic. And kudos and much thanks to all of you guys. I greatly, greatly appreciate it. And I truly am grateful that this conversation is being had on a much broader level than I really ever imagined when I was 20-something years old.
It's kind of funny. It's like, this is what they told us the internet was for at the beginning, right? They're like, yes, you can read every book from every library ever, you can see art from whatever. And what did we do with it?
It took 20 years to get there.
We did we shared just stupid cat videos, yeah, and worse. But this is what it was supposed to be for: connecting with people, enhancing your own trade and your own craft. I kind of loved that. This was like an intellectual stress test for whatever it is we're doing. Most people aren't going to do these types of super insulated assemblies, but thinking about super insulated assemblies helps us think about what's the next incremental step for each one of us, whatever that next step is, and how do I go about achieving that? And that's just great. It's really neat to connect with people from different climates and who are doing different things and learning from that. Very cool.
And one thing, Christine, I want to say is that I was so glad to see your presentation at the beginning of this, because one point that's sort of been weaving in and out of these conversations is how much the context of the wall assembly in the bigger picture of how the shape of the building, the location of the building, the other details in the building matters.
Yeah, exactly. It's everything, context matters. People ask me too, they ask a lot, like what kind of, they ask to recommend a particular material or something, like what's the best kind of whatever, in fill in the blank. Like, well, what are you trying to achieve? And what resources do you have? Depends.
Yeah.
So, I mean, I think we should have a best roof assembly contest.
My
Chris,
gosh.
you're in charge of that. You're in charge
Next
of
year in March.
It's so complicated. Roofs are so hard.
We could do inside corners, outside corners, and Flixo assessments.
Chris, where can we follow you on Instagram for the Sweet 16 roof assembly? # Sweet.
So we have EcoCore has a Instagram account. I think it's ecocore.us. I think I don't use it. That's not my thing. I have gotten off of all social media about 1.5 years ago because it just took too much bandwidth away from things that were more important to me, like my kids.
Fair enough. Why was it Sweet 16? Was it because there were 16 walls? Sorry, I don't get was it a...
So the history of this is really kind of silly. It was just a means of planning out our calendar. Joe and I get together, and sometimes with some of the other guys from the discussion group here in KC, and just sort of like brainstorm, like, okay, what would be fun? What would be a way to get people excited about coming together and talking about building science? Who would be a good guest to have come in and present to kind of just up our game, to educate us here? Because, it's the Midwest. We get everything last. So we try to bring in people that know more than we do and open our discussions with a presentation from someone so that we all have sort of a baseline of knowledge. So that's kind of our standard practice. But we were thinking, what would be a fun thing that we could do that would get people active on social media and might draw a little bit of attention to get people to the meetings, which of course that's not really working right now. We can't get anyone together, but it did work out great to get people involved nationally, and it still worked to the same end. So happy ending.
Good.
And I didn't even answer your question. It was just based on the basketball tournament. So people get all fired up about March Madness. This was set up to run, in March Madness.
Right, but are there 16? I figured it was a sports reference.
Yeah.
I knew it. Are there 16? Is there a 16 thing in basketball?
Yeah, the Sweet 16 in the NCAAs is like the super exciting weekend where all the games are played, and it takes from the big field of 32 down to the Sweet 16. You've advanced past the first round.
Okay, all right.
Yeah, we actually cut assemblies. In fact, Joe and I put together an awesome mock-up of our very buildable and affordable climate zone for almost R30 wall. Well, like, we're kind of running the competition. The least we can do is, back our own name out if we're going to ask someone else to back out.
This year is my first ever perfect bracket.
Well done, Chris.
Well, Matt, Ben, any thoughts before we go? Don't feel obligated, but we did it.
Just happy to have been a part of it.
Yeah, it was fun.
You guys are great. Well, we got to end somewhere. So thank you all for taking the time, and thank you, Christine, Chris, Ben, Matt, Travis, Joe, Rob, all of you. Have a great night. We'll look forward to the next one.
Awesome.
Thanks.
Great. Stay healthy, everybody.